Hello, my lovely friends. My name is Teteje Kepsi Richie, and welcome to my online teaching. Today, our discussion on numerical and computational method will be on finite differences, and our attention will be on finding missing values in two relating values. So, if you have this table, and the values of x are 2, 4, 6, 8, 10, 12, 14, and that of y is 2, 3, 5, 8, 9, then dash dash. What are those values? Can you please guess the value? Your guessing might be wrong. So if the order of the polynomial function connecting x and y is given to us, we'll be able to find those missing values without guessing it. So this will be our discussion today, and it will be very interesting. So please take a seat. So our first example says that we should find a missing term in the table below, given that the polynomial function relating x and y is of degree 3. Remember, I have a video where we construct differences table. We said that if the polynomial function is of degree 3, then the constant in the third difference will be the same. Anything beyond that will be 0, if you remember very well. So, since they tell us the polynomial is of degree 3, all the constants in degree 3 will be the same, and anything beyond it will be 0. I hope you know that by now. So what do we use to do this? We use difference tables. Someone will say 1, 3, 9. This will be 27. And this no, please. They say the polynomial is of degree 3, not 3 exponent x. So that's the difference. So we have a difference table like this. Now we don't know the values here. We don't know the value here. So this is y1, y2, y3. And you can say this is y4. So in place here, we write y4 and all the relating values. Now we find the first difference of y, del y. 3 minus 1 will be 2. 9 minus 3, that's 6. Then y4 minus 9 will just be y4 minus 9. Then 81 minus y4 will be 81 minus y4. I hope you get that. Now find the second difference. That's del square y. So 6 minus 2, that will be 4. Then y4 minus 9, then minus 6. So that's y4 minus 9, then minus 6. That will be y4 minus 15. So here will be y4 minus 15. Then this minus this. That's 81 minus y4. Then minus y4 minus 9. So what are we get? We'll get 81 minus y4 minus y4, then plus 9. 81 plus 9, that will be 90. So we have 90 minus y4 minus y4 will be minus 2 y4. So this place will be 90 minus 2 y4. So we found our third difference, that's del quib y. y4 minus 15 minus 4, that will be y4 minus 19. Then 90 minus 2y4, then minus y4 minus 15. So what are we getting? We get 90 minus 2y4 minus y4, then plus 15. That will give us 105 minus 3y4. So we write 105 minus 3y4. Remember, since the polynomial function is of degree 3, these values here will be the same. Anything beyond it will be 0. So another difference, that's del exponent 4y, the difference there will be 0. So let's try to find. So we have an alternative. So 105 minus 3y4 minus y4 minus 19. So I have 105 minus 3y4 minus y4 plus 19. So add 105 to 19, we get 124 minus 4y4. So we say that the difference here will be 124 minus 4y4, where this is 0. this is equated to 0, and these are the same. So how do we find our y4? So our first one, we can say this, this is a cubic polynomial. So all the values here will be the same. So we can say y4 minus 19 is equal to 105 minus 3y4. So how do we do that? y4 plus 3y4 will be equal to 105 plus 19. y4 plus 3y4, that will be 4y4, and this will be equal to 124. So on divide both sides by 4, our y4 will be equal to 31. This is the first alternative. Now, since it's a cubic polynomial, we go beyond that. Anything beyond that, the difference there will be 0. So we can just equate this to 0. So all 124 minus 4y4 will be equal to 0. I hope you get that. Then minus 4y4 we got negative 124. We divide both sides by negative 4. You realize that our y4 will be equal to 31. So any alternative is correct. So we can say this place is actually 31, not 27 as you presume. We'll solve one more example on this so that you'll be abreast with it. So let's solve our second example. They say assuming that the following values of y squared x belong to a polynomial of degree 4. Very necessary. Compute the next two values. So the degree of the polynomial is given to us. That means when we find our difference table, when we reach the fourth difference, all the constant there should be the same. So we'll construct a difference table like this by writing the values of x here and their corresponding values of y. Since we don't know this one, we say y1, y2, y3, y4, y5. This should be y6, and this is y7. So in this place we'll have y6, and this is y7. So what do? We find the first difference, that del of y squared x. 2 minus 3, that's 1. 5 minus 3, that's 2. 8 minus 5, that's 3. 9 minus 8, that's 1. y6 minus 9, that will be y6 minus 9. Then y7 minus, this will be y7 minus y6. I hope you get that. So let's find our second difference. That's del square of y squared x. So 2 minus 1 is 1. 3 minus 2, that will be 1. 1 minus 3, that will be negative 2. Then y6 minus 9 minus 1, that will be y6 minus 10. Then y7 minus y6, so we have y7 minus y6. Then minus y6 minus 9, so y6 minus 9. So we get y7 minus y6 minus y6, then plus 9. That will give us y7 minus 2y6, then plus 9. So right here, y7 minus 2y6, then plus 9. So let's find our third difference. That's del cube y squared x. 1 minus 1 is 0. Minus 2 minus 1, that will be negative 3. Then y6 minus 10 minus 2. That will be y6 minus 10 minus negative 2. That will be y6 minus 10 plus 2. And that will give us y6 minus 8. So we have y6 minus 8 here. So now we have y7. So y7 minus 2y6 plus 9, y7 minus 2y6 plus 9, then minus y6 minus 10. So minus y6 minus 10. What are we getting? We get y7 minus 2y6 plus 9 minus y6 plus 10. So we get y7, 2y6 minus y6 will be 3y6. Then 9 plus 10, that will be 19. So we have y7 minus 3y6, then plus 19. Now we'll find our fourth difference. So that will be del exponent 4y subscript x. So negative 3 minus 0, that will be negative 3. Then y6 minus 8 minus y3. So we'll have y6 minus 8 minus negative 3. That will be y6 minus 8 plus 3. And that will give us y6 minus 5. So in this place we have our y6 minus 5. Then this, that's y7 minus 3y6 plus 19 minus y6 minus 8. So what are we getting? We get y7 minus 3y6 minus y6 plus 19 plus 8. So that will be y7 minus 4y6, then plus 27. So we have here as our y7 minus 4y6, then plus 27. Since they say a polynomial is to fourth degree, we can stop. Anything beyond it will be 0. You can find a fifth difference, that will be 0 for all. So I don't want to find fifth difference. I want to just use this to solve this. So I can say that my y6 minus 5 is equal to negative 3. y7 minus 4y6 plus 27 is also equal to negative 3. I will do that to find the values of y6 and y7. So we can say that our y6 minus 5 will be equal to negative 3. So our y6 will be equal to negative 3 plus 5. y6 is equal to 2. So we know our y6 now to be 2. Also, y7 minus 4y6 plus 27 will give us negative 3. So y7 minus 4. What's our y6? Our y6 is 2. Then we can say equal to negative 3 minus 27. Ascend the 27. So y7, negative 4 times 2, that will be minus 8. Equal to this will give us minus 30. So our y7 will be equal to minus 30 plus 8. Our y7 is equal to negative 22. So we can say that our y6 is 2 and y7 is negative 23. So this is actually 2 and this is negative 22. I hope you understand that. We solve one last example on finding the missing values in a difference table. So we'll solve one more example on this. They say, assuming that the following value of y subscript x belong to the polynomial of degree 4, compute the next 3 values. We should compute the next 3 values. So what are the values of x? X are 0, 1, 2, 3, 4, 5, 6, 7. Then y, 1, negative 1. 1, negative 1, 1. Right? So someone will say the next will be negative 1, 1, negative 1. No, you need to determine that. You can't just guess. So we construct a difference table for it. The difference table will look like this. We write the values of y, the x, and the corresponding value of y. Since we don't know this one, we said it should be y1, y2, y3, y4, y5. Here should be y6, y7, y8. So we can say this is y6, y7, and y8. I hope you get that. So we find the first difference. That's del y subscript x. So negative 1 minus 1, that will give us negative 2. 1 minus negative 1, that will be 2. Then negative 1 minus 1, that will be negative 2 again. Then 1 minus negative 1, that will be 2. So this place, y6 minus 1, we have y6 minus 1, and this will be y7 minus y6, and this will be y8 minus y7. I hope you get that. Then the next one is the second difference, del square subscript x. So 2 minus minus 2, that will be 4. minus 2 minus 2, that will be negative 4. Then 2 minus 2, that will be 4. Then y6 minus 1 minus 2, that will be y6 minus 3. And this one will be y7 minus, so we have y7 minus y6, then minus y6 minus 1. So y6 minus 1. We'll get y7 minus y6 minus y6, then plus 1. We are going to get y7 minus 2y6, then plus 1. So this place will be y7 minus 2y6, then plus 1. So our next one will be y8 minus y7 minus y6 minus y7 minus 1. So we have y8 minus y7, then minus y7 minus y6. That's this minus that. So we have y8 minus y7 minus y7 plus y6. We have y8 minus 2y7 plus y6. So this place will be y8 minus 2y7 then plus y6. We find a third difference too. So our third difference, which is del cube y subscript x, negative 4 minus 4, that will be negative 8. 4 minus negative 4, that will be 8. Then y6 minus 3 minus 4, that will be y6 minus 7. Then we have this y7 minus 2y6 plus 1. y7 minus 2y6 plus 1. Then minus y6 minus 3. So we have y7 minus 2y6 plus 1 minus y6 plus 3. So that will give us y7 minus 3y6 then plus 4. So here will be y7 minus 3y6 then plus 4. So now we'll find the difference here too. That will be y8 minus 2y7 plus 6 then minus y7 minus 2y6 plus 1. So that's it here. We'll expand. We'll get y8 minus 2y7 plus y6 then minus y7 plus 2y6 then minus 1. What do we have? We have y8. We have 2y7 minus y7. That will be minus 3y7. Then 1 y6 plus 2y6. That will be 3y6. Then minus 1. I hope you get that. So we can say the difference here is y8 minus 3y7 plus 3y6 then minus 1. Now we'll find the fourth difference, which is del 4y, since they say the polynomial is to the fourth degree. So in finding the fourth difference, 8 minus negative 8, that will give us 16. Then y6 minus 7 minus 8, that will be y6 minus 15. Then this one too. That's y7 minus 3y6 plus 4 minus y6 minus 7. We have y7 minus 3y6 plus 4 minus y6 then plus 7. What are we getting? We have y7 minus 3y6 minus y6. That will be minus 4y6. Then 4 plus 7. That will be 11. So we have here to be y7 minus 4y6 then plus 11. The next one is y8 minus 3y7 plus 3y6 minus 1 then minus y7 minus 3y6 plus 4. So in getting that, we expand is y8 minus 3y7 plus 3y6 minus 1 minus y7 plus 3y6 then minus 4. So have y8 minus 3y7 minus y7, that will be minus 4y7 then plus 6y6 Then minus 1 minus 4, that will be minus 5. So this place we have y8 minus 4y7 plus 6y6, then minus 5. Having known this, since they told us that the polynomial is of degree 4, all these values should be equal. That means y6 minus 15 should be equal to 16. I hope you get that. Then this will be equal to that, this also equal to that. We equate to find the values of y6, y7, and y8. So we can say our y6 minus 15 is equal to 16. So y6 will be equal to 16 plus 15. y6 will be equal to 31. So we have found the value of y6. Also, this is equal to 16. So we can say y7 minus 4y6 plus 11 is equal to 16. So we have y7 minus 4. What's our y6? That's 31. We have found it. Plus 11 is equal to 16. So we have y7. 4 times 31. That will be 124. So minus 124. Then plus 11 is equal to 16. So we have y7 minus this negative 124 plus 11 will be negative 113 equal to 16. So y7 will be equal to 16 plus 113. y7 will be equal to 129. So having gotten the values of y6, y7, we can also say that this value y8 minus 4y7, so y8 minus 4y7 plus 6y6 minus 5 will also be equal to 16. I hope you get that. So we substitute. So we have y8 minus 4 times y7 is 129, then plus 6, y6 is 31, then minus 5 should be equal to 16. So y8, 4 times 129, that will be minus 516. Then 6 times 31, that will be 186 minus 5 equal to 16. So minus 116, minus 516 plus 186 minus 5 will give us minus 335 equal to 16. So our y8 will equal to 16 plus 335. y8 will be equal to 351. So we know that our y8 now is 351. So while 6 is 31, y7 129, and y8 is 351. Then we can say that the value here is 31, the one here is 129, and the one here is 351. I hope you get this. So we'll end it here today. Please remember to subscribe to my YouTube channel before you sign on. Do well to check out my other videos on finite differences on YouTube. Until we meet again, my name is Kepsi Richard.